Hey everybody, my name is Daryl Obert, and I have the pleasure of having Martin de Lasa with me today, and we're going to be talking about performance inside of Maya 2016. There's been significant improvements in this release, and Martin is responsible for a lot of these, or him and his team are responsible for a lot of these. So what's going on? What's changed?
Yeah, so just to set the record straight, I think we had a really large group of people working on this over the last year, and this involved people ranging from dev and QA to automation. And really the reason we had so many people focus on this problem is because this is like the number one thing that has come up over year after year when speaking with customers. So, as you can imagine, as films have gotten more complicated.
Games too?
Games and TV shows as well. The complexity of rigs has been consistently going up. People expect, richer visual experiences, more expressive puppets, and so they keep throwing, more complicated rigs at Maya, including muscle systems and all kinds of deformations, and Maya hasn't been keeping up.
Okay.
And really, the fundamental reason for this is that Maya's legacy architecture was designed back in the day when most computers had a single core. And since then, computers have evolved a lot, and most of the computers that you and I own today have, at least 4, if not 8 or 16 cores. And really, those computational resources have been sitting idle under your desk up until now.
So it's wasted money.
It's wasted money. I mean, it helps maybe lower your energy bill by heating your house, but
kick your renders in. Renders like
that's
that
right. But in terms of evaluation speed, it hasn't really helped you. And so we had tried to solve this problem in the past, and for a variety of reasons it hadn't materialized. And really because of the effort of the team over the last year, we were able to deliver now a Maya that can take advantage of the hardware that you already own, and this includes both the CPU resources as well as the GPU resources on your graphics card.
Awesome. So big team effort, lots of input from lots of people, our clients helping us out, figuring out, sending us scene files.
That's right.
Lots of testing happening.
Right.
And we ended up with pretty significant improvement in Maya 2016. So let's walk through that now and see it in context. So what we've got here is this is a pretty typical rig. Obviously, it's got a custom control rig on top of a character, and it's just a simple little walk cycle. And we've got our file set up in the kind of classic mode. So this is going to be playing back sort of like Maya 2015 prior. So first thing I want to do is just go ahead and turn on some of the heads-up display to show the evaluation mode. So this is going to let me know how this scene is being evaluated. Is it using the new technology that's in 2016, or is it using sort of the legacy mode or the DG evaluation mode?
Right.
So with DG on, and again, this is sort of what we would expect to see inside of Maya 2015
and prior.
Yeah. We're getting 10, 12 frames per second.
Right.
Which is okay, but not really what an animator wants, right?
Yeah, so it's not quite interactive, and so this would make it, I think, harder to get this this puppet to really move in an expressive way, in the kind of manner that people want.
Okay, so we have something that helps us figure out how Maya is using the resources of the computer in the form of the profiling tool, which is also really significant, and they kind of work hand in hand with this new evaluation mode. So let's just bring up the profiler, which is under Windows, General Editor's Profiler, and let's run a quick evaluation of how Maya's using the resources of this computer. So we've turned some stuff on and off. Let's just turn on Dirty Prop here, and we've got Viewport 2.0 main evaluation and Dirty Prop. And our frame buffer is set to a value of 5. So we'll hit playback on this, and while it's playing back, we hit start record, and this is going to stream data in here. So what are we seeing here? What is this picture that we're being provided with?
So why don't you just select a frame and we'll walk through this, and this will also help people watching understand what the difference is between the old way of doing things versus the new evaluation manager. So go ahead and frame that.
Okay, so to frame it, all you have to do is hit A.
Yeah.
So we'll just do a frame.
Right. And so here what you see is that is kind of the classical, the way that Maya has been spending time evaluating each frame of your animation up until 2016. And so really you can think about this as involving 3 steps. The first step we call dirty propagation, which is let's figure out what we need to evaluate, and that's shown in pink there. The next step is, well, now that I know what I need to calculate, let's go and perform the math, and that's the evaluation. Okay. And the last step is, well, now that I've updated the state of the scene, let's draw it, and that's the rendering. Right. And so in this particular case, I think if you were to marquee select that whole region, we're spending about 90 milliseconds evaluating this particular scene.
Okay.
And so what we've done in Maya 2016 is that we're reading in your existing Maya file, and we're converting that to an alternate representation. And the advantage of the alternate representation is that although it uses dirty propagation to build the evaluation graph, once we have that evaluation graph, we turn off dirty propagation.
So you do it once.
We do it once. And so that approximately 20 milliseconds that you're spending in dirty propagation is going to go away.
And you can see before it was being done for each frame.
That's right. And then once we have that evaluation graph, we can smartly schedule that graph across the resources that you have on your computer, be they CPU or GPU. Okay. And the really critical thing to understand here is that we spent, one of the things that came out of our prototyping efforts was that we had to make sure that this worked with your existing scenes, because people have a large investment both in pipelines and in plugins. And we wanted to make sure that when they open up their legacy scene, that they didn't have to rebuild everything from scratch or use fast nodes or anything of the sort. So
cool. There are a couple other views here that I want to dive into.
Sure.
Because when I was first picking the tool up, I didn't understand what these did. So I had the luxury of being able to call you up and say, hey man,
what's up?
Why would I go to CPU view? Why would I go to threaded view? So
yeah.
Let's just talk about this in the classic DG mode, because I think this is something that's really pretty interesting when you get a sense of how those CPUs are being tapped into.
So right now we're in what we call the category view, which as you can see, what it does is it divides up the work based on the type of work that's performing, be it evaluation or dirty propagation or rendering. So if you go into the CPU view, what you'll see now is that the work that has to be performed is divided in terms of which core on your machine is doing the actual work. And there's, something that obviously jumps out here, which is that in this case, CPU 39 is doing the bulk of the work, and then there's a little bit of work happening here and there, but for the most part, most of the CPUs are sitting idle and they're not really contributing to evaluating your scene.
Right. So that's not what you want to see. That's not a pretty picture.
Well, it just means that right now the scene has a really low level of concurrency, and we can do better.
Okay, so let's check out what happens once we jump over to the next mode here. So if we jump into the preferences and go to animation, you can see that we have DG, and then obviously there's 3 modes here. So serial and parallel. What is serial all about, and why would anyone ever need to do that?
So in this particular case, we started in DG because we're trying to explain what these different modes are. When you start Maya 2016, by default you'll be in parallel. And we'll see what that's all about in a second. Serial mode is really meant to be a debugging mode for riggers and plugin developers. Really, the key thing to understand is that before you want to make your scene fast, you have to make sure that the answer is right, because it's easy to make the wrong answer fast, but people care about, if they've built a particular scene, they want to see that scene play back. So if you open up Maya 2016 and you see that with the default parallel mode, it's producing an answer that doesn't look right to you. Maybe the geometry is in a different place than you expect. You can use the serial mode to troubleshoot and to eliminate threading-related issues.
And that would be specific if you were using plugins or something. Like the standard Maya tools, you shouldn't need to go to the serial mode.
Yeah, so if you are using lots of plugins, you can this may come up because sometimes plugin authors do clever tricks to reduce the amount of computation, and those things can mess up the parallel mode. From what we know, the out-of-the-box Maya nodes should work in parallel mode. If people see otherwise, we want to know about that.
Sure. Tell us, please.
Yeah, tell us. But I think the other thing to keep in mind here is that the serial mode really has not been optimized for performance. The goal is to troubleshoot and help you debug problems. And so there's many cases where, like, even though the serial mode is building the evaluation graph and using only a single core, like the DG, it might run slower than the DG. And so that's not a bug. It's just we haven't really optimized that because it's meant for troubleshooting.
Okay. So let's go ahead and jump over to the parallel mode. It's also worth mentioning that profiling tool, if you've made plugins, you can have them also be instrumented, right? You can mark them up and get them to be included in their own little categories in the profiling tool.
Yeah, so we've added some API enhancements that let you change your plugins to make them more parallel friendly. And we've also, as you mentioned, we've added some API enhancements that let you specify the color and the category, maybe the subcategory of a particular event. And so that will let you mark up your plugins, and then they'll show up in the profiler, just like the nodes that we've instrumented.
Right, so you could use that to troubleshoot your plugin too.
Absolutely, and that applies both to C++ and Python plugins, depending on what you prefer.
Sweet. Let's check out what happens to our rig in parallel mode. So we were, 10 frames per second before?
I think that's right, yeah.
So we jumped to parallel mode. Notice that it says rebuild required. So The rebuild is basically doing that dirty prop at the beginning.
So the rebuild is telling you, well, something in the scene has changed. You may, when we have an evaluation graph, but it may be invalid, so we're going to have to rebuild another one. So you're gonna hit play, and that graph is going to get rebuilt. And it's worth stressing that rebuilding the graph in almost all cases is almost an instantaneous process. It's not something that requires lengthy offline computation.
All right, so this is what the view looked like before, and again, each frame had that dirty prop.
Yeah.
And then you can see how the data is sort of stacked up here. So remember what this picture looks like. This is again how the machine's utilizing its resources in kind of the classic legacy mode. We've turned parallel on, so let's go ahead and play this back. So obviously, pretty significant speed improvement. We jumped up to 32 frames per second.
3x, yeah.
I like that. Thank you.
No problem.
I'll take it every time. And let's go ahead and record this and see what happens here. So obviously that's a different picture, right? We've lost that whole dirty prop on each frame. It's obviously now just going through and executing. And the stack looks a lot different.
Yeah, so there's a couple of things to point out. So first of all, as you mentioned, the dirty propagation is gone, and that's because the evaluation graph has been built, and now we can shut that part of Maya off, and we'll take that savings in time to speed up your scene. The other thing you're seeing is that unlike those pyramids that we saw in the past where there was really only one thing happening at a time, now we're seeing multiple tasks all happening at the same time. And this is going to be particularly evident if you bring up the CPU view. So now, unlike in the previous picture that we saw where we had only a single thing happening at a time, there's tasks happening concurrently on multiple cores of your machine. And so really, we're starting to take advantage of the hardware that's already sitting under your desk simply by flipping that switch.
Cool. So there's also some big bars in here, right? So that's starting to tell me some stuff, right? Like those are the big red flags, right?
Yeah, so in case it's not clear, I mean, the size of that bar really is an indication of how much time is being spent in computation. So when you open up the profiler, what you want to do is you want to take a look at what the big bars are and then try to understand how those nodes or operations are associated with the rig that you've built.
Cool. So what we're seeing here is obviously when I select a node in the profiler, it's picking it in the viewport 2.0 as well as in the Activator. It's selecting the node for me. So I'm starting to see that these are all deforming pieces of geometry.
Yeah. So
they're all meshes.
So I think what you'd find here is if you open up the node editor, because you already have that node selected, you would find that those meshes are attached to deformers. So if you just go and hit the little arrows there, do it a couple times, right? Do it one more time. So you see that you have a skin cluster feeding. Oh, maybe one last time. There we go. So you have a skin cluster essentially feeding into that arm shape. And so really you have a deformation chain that is slowing you down.
Okay. So the slow stuff right now is deforming geometry.
Right.
But we still went from 12 to 30.
Right, so that's a big gain. But so the really cool thing about the evaluation manager is that by separating the description of the scene from how things get evaluated, we can target specific chains of computation or subgraphs of that evaluation graph to specific hardware on your machine.
Okay.
And this opens up a whole bunch of really interesting opportunities. In Maya 2016, what we've done is that we've used that mechanism to target deformations on the GPU. And so conceptually what's happening is that instead of doing all the deformations on the CPU and sending the deformed geometry to the renderer, we send the undeformed geometry to the GPU override mechanism, which we'll toggle in a second, and then we do the deformations using OpenCL, and then we send the deformed vertices directly to the VP2 render buffers and render the scene without having to have expensive readback.
Awesome. And since it's OpenCL, it's going to run on any GPU.
Right. And it runs on all the OSs that Maya runs on.
Excellent. So we'll turn on the GPU override, and we'll see what happens to our playback one more time here. So now you'll notice that the GPU override has enabled, and there's a little number there. So what's this number telling me?
Yeah, so what it's telling you here is that you have 63,000 vertices that are being streamed onto the graphics card, and so we're doing deformations for 63,000 vertices in this particular scene on the GPU, and so this is going to give us an extra boost in performance.
So again, we went from 30 almost up to 56 frames per second.
Well,
so
actually, we started at 10, right? In
we
DG.
did in DG. So that's pretty amazing, right? And obviously, if we run this, you can see now the big bars are all gone.
Yeah, the big bars have been replaced by those little yellow boxes, which are the deformation that's happening on the graphics card now. So we've really compressed those deformations. We haven't done anything to speed up rendering, mind you, because really the work in 2016 is focused on improving evaluation. But we've increased the parallelism of the work that needs to happen using the parallel mode, and we've really accelerated the deformations using the GPU override.
Nice. There is one thing that we can do to help Viewport 2.0 a little bit, and that is by jumping over here, and we've added the ability to hide things on display layers, right?
Yeah. So
we did do one thing to help.
Yeah.
Later,
So
right?
there's a few
Tricks.
targeted improvements.
Yes.
One of the things that animators told us over and over again is that although they need the controllers to pose the characters, really they want to see the silhouette of the character when they're animating and playing it back. So we added this hide on playback feature in the render layers, which by toggling it will automatically hide the controllers or any object that you add to that render layer when you hit playback or scrub in the timeline.
So yeah, we've gained a few more frames per second there by hiding those controllers. So let's jump into another scene and check it out.
Let's do it.
So the next one that we're going to look at is going to be the file that I used to actually launch Maya 2016. So it's a scene from Hyperspace Madness, which is an internal production that is used by all the developers to sort of use real assets.
Right. I think Juggernaut was from that production.
Yeah,
right?
this is actually from it also. So in this file, let's try to find some errors, some things that haven't been turned on, and try to get some more speed into it. All right, so we've got our file up, and what we want to do is we want to go ahead and, again, see what we're going to do to get some performance in this. So you can see that we have parallel turned on, rebuild. It needs to obviously do that dirty prop. And right off the bat, there's not anything that's hitting the GPU. So if we rewind that and hit playback, you can see that our frame rate it's okay. It's around 10 frames per second, and there's about 50K of verts that are being shoved onto that GPU, and that's basically because we've got this ship in here. And it's worth mentioning, we call it parallel rig evaluation, but it really is kind of parallel scene evaluation. So it doesn't have to be a character rig. This ship has IK in there. It's got animated objects, parented into bones. So for all practical purposes, we've got two characters in our scene right now, and a lot of heavy lifting being done by Viewport 2.0 to get this rich visual fidelity that we're seeing in the scene.
Right.
But
so the scene the evaluation manager will accelerate situations both where you have a single complex rig, which maybe has a whole bunch of independent parts, and also a scene such as this one where you have multiple different characters, each with its own rig, that are independent of each other and aren't constrained, and so you can really be evaluating those things simultaneously.
So the problem is this character isn't my scene isn't fast enough. So what do I do?
Well, open up the profiler.
This is the first thing that I learned. So go to the profiler. It's going to tell you what to do. So let's go into the profiler. We'll queue up our scene here. We'll get it playing back, and we'll hit record. It's going to stream in the data here, and you can see lots of stuff happening stacked on top of each other. But really quickly, we start to see there's a couple things. There's some skin clusters here that are kind of slow, right?
Yeah. So there's two things that you can remark if you just zoom out a little bit. So you have a short period of high concurrency in your scene where there's lots of things happening simultaneously, and then you have followed by these big long tasks which are both lengthy and are really slowing or limiting the amount of parallelism you have in the scene.
So let's go ahead and address that. So if we just select one of those guys, if we rewind this, like we saw before, it's actually going to select the node that's got the problem. So this character, if we frame in on it, is basically built with a lot of creasing on it. So it's got soft and hard edges. So this is something that OpenSubDiv really excels at. I've obviously got OpenSubDiv turned on for this character, but it's playing back slowly. So why is that playing back slowly? Let's jump into the attribute editor and see what's going on here. So subdivision method set to OpenSubDiv, but there's a new attribute called OpenCL acceleration. So I got to turn that on. I have to turn that on to get this to be fast.
Right.
So why is that there?
Really, what we're doing is we're taking advantage of the same GPU override that I described earlier that targets deformations on the GPU, and we've accelerated OpenSubDiv using the exact same mechanism. So if you go and check that option box, now what's going to happen is that any meshes which are accelerated that are smooth mesh previewed with OpenSubDiv will also get accelerated via OpenCL.
Okay, so I turned that on, and my count didn't change. If I hit playback here, you can see that we're not going any faster. Why what's going on?
Let's see what the profiler tells us. So presumably that suit shape will get smaller now because now it's getting accelerated. So let's take another look.
Okay, well, I think I know what's going on. I'm going to supersede that with it needs a kick.
Oh, right. Yeah, so thanks for reminding me. So there are situations where the GPU override won't detect that you've made changes to your scene.
Yeah, let's get this framed
and
up
that's
where you
actually
can
one of
see
the
it.
reasons we haven't turned GPU override on by default in Maya 2016. There's also some driver instability issues that we need to address. So give it a kick by toggling that button, and I guess now we've gone up from about 50K to 142, so
Yeah,
it seems promising.
That's a good sign. When that number increases, you know that something else is going to get shoved under the GPU, and you can see that we're now up to 24 frames per second in our scene. So really, that's what an animator wants. You get over 24 frames per second, you've reached your goal, basically.
Right.
So don't be afraid to give it a little nudge. If you turn something on and you're expecting to see a change in that count, there's a good chance that you just need to kind of give it a little.
Great point.
Give it a little kick. So the next thing that we want to talk about with this scene file is what happens when it's one of the things that I found a little odd. Like I get my character in the scene, he's in his T-pose, I haven't done any animation yet, I've got everything set up the way I think it should be, and it's not playing back fast. I'm posing my character and it's slow.
Right.
So I'm going to go ahead and delete all the animation on this and show you that, and then have you explain why.
Great.
I understand it because, again, I had the luxury of calling you and being like, hey, what's going on?
Yeah.
Because I would spend a little bit of time and be like, it's broken, and no, I'm using it wrong. So let me prep the file really quickly by getting our character to his stance pose. And you got to untie him really quick, and we can delete all by type, all of our history, or all of our channels. So there's no animation in my scene anymore. His neck looks a little funky there, so we'll just kind of pull that up. So I've got my scene. It says rebuild required, so I hit rewind. It rebuilds. Everything's ready. So the dirty props happened here.
Right.
But notice that there's no animation in my scene. Before we had 140K sitting on the GPU. Now there's nothing on the GPU. If I grab this character's arm and begin moving it, it's worth mentioning, this rig's it's a pretty sophisticated rig. It's got squash, it's got stretch, it's got the ability to be posed with FK and IK. So it's pretty hardcore rig. And when I grab it and I start to move it around, the performance interactively isn't that great. And I'm not seeing any enablement of the GPU override here. So why, when I was playing it back, was it playing back at 24 frames per second, and now that I'm interacting, imposing my character with no keys in the scene, am I not getting that same performance?
So the scenarios that we covered before really focused on playback, and we want to make sure that this applies not only in playback but also in manipulation. So I think the key thing to understand here is that for us to build, we try to build as small an evaluation graph as possible, and by doing so, we make it fast to rebuild, to schedule, and to evaluate. So really, the only things that we include in that evaluation graph are the things that are keyed or animated.
Okay.
And so in this particular case, you've blown away all the animation in your scene, and so nothing is keyed. All the values are static, and so you have a really small evaluation graph, and none of the things that you've been manipulating are in the evaluation graph.
Okay.
So right now, what's happening effectively is that you're dropping back to DG evaluation while manipulating. So if you want to take advantage of the fast evaluation manager, what you're going to have to do is drop a couple of keys on that controller.
Okay, so let's go ahead and do that. So we'll just hit S, and we'll just move forward in time here. We'll hit S one more time. As soon as I do that, now that I've got two keys on there, you can see that the GPU is now contributing to the evaluation of the scene.
Right.
That's a positive sign whenever you see that number go up. And now you can see as I scrub, my frame rate, or as I pose my character, is back up to around that 24 frames per second. So it's interactive to work with.
Right.
Here's something that's interesting. If I grab this arm, or this hand over here, it's still slow.
Right. So that arm is independent of the other one that you keyed, and so until you key that other arm, you're going to have the exact same problem.
So it looks at each limb individually. It looks at each path individually, kind of.
So I think that's an overgeneralization. I think what you can say is that depending on how you've built your character, it's going to look at the evaluation paths that are independent, be it a leg, an arm, or maybe you've built your rig in a way that all those things are coupled together. Maybe they're all holding a ball or something, and so they can't be evaluated independently. But if they can, you're going to have to key each of those things separately because they will be evaluated separately.
Okay. So if I wanted this arm to play back as fast as the other arm, all I have to do is hit
drop some
key,
keys, yeah.
drop another key on it over here, and now we've got both limbs playing back imposable at the rate that I would expect, the same rate that I was getting
And
the
you've
playback.
increased the number of verts being streamed on the GPU. Now you're up to 101.
Yeah, probably because that little arm gun thing or something's getting
Right.
included in it. Cool. All right, so let's jump into another file and look at something else that I found kind of interesting. So when I was working with building these assets, there's the guys that are doing the short, HSM short. They hand their files off to me. I have to build demos out of them. So they're making crazy film production assets, right?
They're going to town.
They're going to town. They're making stuff kind of crazy, right?
Yeah.
So I get this stuff, and I'm like, I have to build a demo. I have to clean it up. So when I got the file, the little Trillobot guy that I got, my file was playing back slow, and he was brought in with a reference. So I'll show you what I got and the performance bottleneck that I found in it using, again, that profiling tool to kind of address that. So we'll bring open the film version of the Trillobot prior to my optimization, and I'll show you kind of the same workflow. We're going to be driving the same workflow over and over.
Right.
Go to the profiler.
Right. The key thing is, stop guessing. There's certain kind of rules of thumb and lore that have developed around, what makes Maya fast and slow. Some of those rules have changed now with Maya 2016, and the profiler really is your friend in guiding your optimizations.
So this is playing back. Look at that number. It's sending almost 1 million.
It's actually animated, but you can't tell, right?
Yeah. Well, the animation starts a little further down the line here. So off it goes to go blast Sven or whatever. And the interesting thing here is this is a pretty big asset, right? Like it's 1 million verts on the GPU, and it's playing back at 20 frames per second. But I know it can go back. We can do better, right?
Right.
So let's run that profiling tool and see potentially where the problem with this guy is. So we'll bring up the profiler one more time, and with that profiler up again, we'll just hit playback. Oops, let's playback forward here.
It'll work backwards too, but
nice. I don't work backwards.
Bidirectional.
So, yeah. All right, so let's just frame in on this guy, and you can see lots of concurrent execution happening here.
Right.
But big bar right there. So what is that?
Looks like it's the polynomial per vertex. So I guess if you bring up the attribute editor, it'll automatically select that node. So.
Okay, let's check that out. So there it is. It's already automatically selected. So that's basically sloppy, right? We don't want that in there. Now I could. My gut would be, when I'm trying to figure out what's making things fast or slow, my old workflow would be hide. I'd hide half my scene, did it get faster? I'd hide that half if it didn't get faster.
Right.
And that would be my troubleshooting to try to find the bottlenecks inside of Maya. That doesn't seem to work anymore.
Yeah, so the optimization that you're referring to is something that was put into Maya really early on. And the idea is that since we want to focus the animator's work, anything that's hidden is not evaluated. But in the new evaluation manager, that optimization isn't in place yet, really because our main focus was to put out a really stable version of Maya that worked with existing assets. So what we've put in place as a temporary placeholder that we plan to build on is this frozen attribute that's been added to all nodes.
Okay.
And what the frozen attribute will do is that it'll remove that node from the evaluation. And so it's, especially in the context of like a reference where maybe like the asset is read-only and you can't edit it, it allows you to temporarily remove something from the evaluation, and then once you've validated, well, this is my problem, you can go and modify the original asset.
Okay, so I've got that frozen turned on, and you can see our frame rate's now back up to where you'd expect it to be, in the 50s.
Right.
For moving around
so
a
much
million.
better.
Much better. Obviously, it doesn't go along for the ride because we froze it.
Right.
So the workflow to fix this would be delete non-deform history and get rid of that weird, costly.
Yeah, some of that is kind of rig specific. For maybe the person had a really good reason for including that polyvertex per node. If it's really not necessary, you can just blow it away.
Right. So. I have to blow it away. It's too slow with it. I don't like it. All right, so let's jump into another file here and look at some other examples of using the profiling tool and using the parallel evaluation to find more speed. And I think this next one that we're going to talk about is this little dude here, who's actually provided to us from one of our clients. Moonbot Studios provided this to us. It's a really interesting facility in Louisiana, of all places. And they do all kinds of cool stuff. They do books. This is something from a mobile game that they do. They recently won an Academy Award. So the animated short that they did won an Academy Award. So awesome group of people. And what we've got here is this little guy. And if we play it back, it looks cool. But the performance isn't where we want it. It's not 24 frames per second.
So just to provide some context, can you just jump into DG mode for a second and we'll see,
sure.
Like, what would this scene have run at in Maya 2015?
Yes, good point. Oops. It applied. So 6 frames, 7 frames per second. So DG mode's about half as fast, which is I think pretty awesome. You know, it's still not 24 frames per second, but doubling your speed anytime is good.
Right.
And there's more speed to be found in here, right? So we've used a profiling tool to find stuff. Is there any other way that we can, you know, any other tricks you have to find potential bottlenecks or things that aren't?
So I mean, it kind of depends on what the bollneck is. So I think if you go and switch to parallel mode, and then we bring up the profiler, we can take a look at what might be slowing us down.
Okay.
So why don't you go ahead and do that? Settings, animation, yeah. Make sure you give the GPU override a little kick. Great.
Okay.
So save, and let's try it again.
So we'll get the profiler up.
Great. So hit play.
Ooh, I don't like it backwards. I know you say it's possible. I don't trust you. So we've got some stuff in here that's obviously.
Right. And it looks like for this particular rig, 0K verts are being streamed to the GPU. So there's something preventing us from using the GPU override to accelerate deformation. So one of the commands that we've provided in Maya 2016 is something called Deformer Evaluator. And I think you've created a shelf button.
I did, yeah, and I actually have the command sitting down here in my mail window
Great.
too, right? So we can just kind of zoom in on that so you guys can see what that is.
So if you go ahead and select why don't you go ahead and select the main mesh on the character here.
Got it.
Great. And just run that command.
Okay.
What this will do is it'll give us some feedback in terms of what specifically is stopping the scene from targeting deformations on the GPU. And so I think the interesting thing here, so you've selected GeoShape Deformed, and it's telling you that you have a fan-out connection. And so that's kind of a cryptic message, but what you can do is if you bring up the node editor still with that mesh selected, you'll notice that there's essentially a series of nodes that depend on the state of that deformed geometry. And so in this particular case, it looks like there's some follicles or maybe some buttons attached to this character. And so the thing to understand is that right now, read back from the GPU to the CPU, so if you perform some deformations on the GPU and you send the result back to the CPU, that's a really expensive operation with today's hardware.
Okay.
There's some new standards that may change that in the future, but really the GPU override is meant to target deformations where you don't need the result back on the CPU pad.
Okay.
So for the purposes of this experiment, why don't we just try blowing away those follicle shapes? There's one more. There you go. Yeah, blow that away. And you may have to give it a little kick.
Yes. Let's see. Let's see what happens if we don't. Yeah, nothing
so
happened.
Kick required.
So just give it a little nudge.
And again, if you had saved this and
Oops.
if you had saved this and you had loaded up the file, that kick wouldn't be required. So the other thing to understand is that for the GPU path to work, your mesh has to be sufficiently dense. And so the reason for this is that it's actually faster to perform deformations on the CPU path if your mesh is not very dense. And as the mesh gets denser, then we can start taking advantage of the parallel nature of the GPU. So it looks like now with the HUD, you have about 1,200 verts on that mesh. So if you refine that a little bit,
we'll just hit 3.
yeah, and actually running the poly HUD count while you're animating slows down your scene. So why don't you hide that now that we're up above the 20K mark?
Okay.
The display HUD, there you are.
Display, poly count, get rid
Great.
of that guy, and just give it a little boot there.
Great. So now we have 19,000 verts on the GPU, and if you hit play, we'll hopefully see a commensurate improvement in speed.
Okay, so it got a little faster.
Great.
So there's still some stuff in here slowing it down. Now, we talked about in the past, I kind of did a couple webinars and blogs about performance saying, stop using expressions, start using math nodes. And a lot of riggers, obviously, this guy's got squash and stretch in here. A lot of this rig is actually done using utility nodes. If we looked in the outliner or in the Hypershade window, actually, we can just get to it like this, you can see that this scene is already set up if we go to the utility nodes, using a ton of math nodes to do that squash and stretch rig in there, which is what you'd want. But there's still some expressions in here. So what happens with the evaluation of your scene when you have certain expressions, certain types of expressions?
So I think so far we've been talking about the parallel evaluation in a kind of a conceptual way, and there's kind of an underlying assumption that everything in your scene can get parallelized and it's safe to do so. the reality is that both the plugins and the internal Maya nodes may have some real reasons for why they can't be run at the same time. And expressions is a great example. So expressions, if you think about what's inside an expression, it's a mel command. So that mel command needs to be run by the mel interpreter. And sometimes the mel commands inside those expressions are really nasty things like getAttr. So getAttr is nasty because it's introducing a dependency in your graph that's implicit. It's not really recorded in the evaluation graph.
Okay.
So generally speaking, by default, we schedule expression nodes as something we call untrusted, which means nothing else can be running at the same time as the expression. However, if we find that your expression node is simply a bunch of math operations, we can bring it up to a high level of scheduling. So having said that, whenever possible, you should avoid expressions because they're still limited by the fact that only one expression can be calling the mel interpreter at any one time.
Okay,
so.
And if we look in the expression editor here,
so you have a handful of expressions.
We have some expressions, and there's actually a few that are kind of costly that could be re-represented with simple math nodes, and they're actually shading things, tying into other shading things, and then divided by 2. So if we just blow these guys away, and I think there's 3 of them in this scene file. So I'm sorry to Moonbot Studios, I'm deleting your expressions, but for the demo, I could obviously rebuild those.
Right. There's other ways of doing
There's other ways of doing that, but we're just going to blow them away for now, just to see what that does to our speed. So we were 16 frames per second before.
Right.
Let's kind of frame ourselves up here and see what we get back to. So, you know, it's a little bit faster now. We're up to. Didn't get much faster.
Well, I got into the 24 frames per second range. I think there's still one other thing we can do here, which is to combine some of the geometry in the antenna of the character.
Good point. So this is something that Viewport 2.0 doesn't deal well with, as well as it should, honestly. So what we've got here is we've got some objects that are essentially these little puff balls, and there's a whole bunch of these little pieces of geometry inside of here. So what we're going to do is we're going to combine those together into one polygon and then parent those back into the rig. So just hit the up arrow key. I've got a little script that basically goes through and does a poly combine and then deletes the history. So we'll just run through that really quickly. And after we get through combining each one of these little puff balls into a single mesh without any history, we can parent them back into the hierarchy of that rig. And we'll just hit the P key to do that last operation. So now that we've done that, we can kind of zoom back out here and see what happens to our scene. So we've gotten it running, you know, much better than it was before. In the DG mode, it was like 6 frames per second, right? So 2015, you would have been at 6 frames per second, and now we're up to above 24. So close to 30 frames per second. So again,
roughly 5x improvement in performance, and like well into the realm of the interactive. So you can imagine actually animating this character and you know, really getting a sense for the motion and you know, which at 6 frames per second is just it's not going to fly.
Right, you're doing play blasts.
Right.
And now you're not.
Right, and so that's another thing you can conceptually think of some of this work as really eliminating the need for play blasts for specifically, you know, for these types of scenes.
Cool. All right, so we've got one more example that I want to show, and that is from this old file that we put together, Gwen and Dave. So you guys have probably seen this one before. What we have in this file is showing something that isn't supported, right? And the idea is it's not supported, but there's legitimate workarounds that are probably better practices than using this workflow. So this object right here, if we look in our wireframe mode, is just a sphere. That sphere is parented into the rig, and it has a jiggle deformer on it. So that jiggle deformer moves at a vertice level. We've added that sphere into this object as an influencer object, just in the skin cluster.
Right.
So for those vertice level movements to deform that skin cluster, you have to have use component turned on. Use component isn't supported.
Yeah, so far I've talked about the GPU override, and I actually haven't told you the supported deformers. So we work closely with customers ranging from film, games, and TV, and we got lots of data from them. And we really approached this in a data-driven manner where we looked at the kinds of things that people were doing, and we targeted the deformers and rig patterns that we saw coming up over and over again. So by doing that, what we did is that we included 6 deformers in the GPU override. Those are skin cluster, blend shape, cluster, tweak, group parts, and soft mod.
Okay.
So 6 of them. And as you pointed out, not every single option in those deformers is currently supported. Sometimes it's because those things are rarely used, and sometimes it's because really there's a better way of doing things. So use components is typically you can use a wrap deformer or some other deformer wire to achieve a similar effect.
Sure.
And so rather than continuing to encourage people to maybe abuse Maya in ways that were kind of not consistent with the original design, we're trying to encourage people to move towards other kinds of deformers. There's a whole bunch of deformers supported in Maya, and sometimes people get stuck. Maybe they have a script or something that's generating the character for them, and there's other ways of building the rig that are more flexible and more efficient. So.
Okay. So let's just see this in context. So we've got this little jiggle deformer on here. I've got a little animation on this guy. So if we hit playback on here, you can see that it kind of moves up, and we're moving at 7 frames per second. And you can see when he stops, there's a little bit of jiggle happening.
Right, some passive belly fat there.
Yeah, I'm having fun here, right? But if we turn off the component, use component on this guy, and play it back, the sphere is still going to jiggle, but the character doesn't jiggle anymore. So you can see that we've really improved the performance of that character. We've doubled or tripled the performance again. So instead of having that added in as an influence in the skin cluster, I would have just added it as a wrap, and it would have been just as fast.
Right. And the other thing to keep in mind is that another way of thinking about this is that it really lets the animator control where they want to be on the quality performance continuum.
Okay.
So if they want to pose the character and they essentially ignore that jiggle temporarily, they can turn off use components. And if it's really critical as like a secondary movement to their shot, they can always re-enable it, but they're not paying the price for that all the way through.
Okay, very cool. So that's pretty much it. I'd like to thank everybody for taking the time for watching the webinar. Thank you and your team so much for making these. As a Maya artist, I can say it makes my day better. So thanks to the team. I'm sure there's a bunch of people that worked on this.
So as I mentioned earlier, we had a group of people that worked on this, super diligently over the last year. People have worked really, really hard. I want to call out our senior architect, Gordon Bradley. He and I worked together on the prototyping phase of this project, exploring different technical solutions. Our technical lead, Christian Legenza, a lot of the things that we talked about today are born of his initiative, and he was really instrumental in pushing some of these ideas through. And then really a whole bunch of people that spanned, dev, QA, automation, and really our customers as well, because we could not have done this without real-world data that was representative of the different ways that people are using Maya.
Right. Both film, TV, and games.
Yeah, across all the different kind of segments of the industry that use Maya today. And I think the other thing that I want to ask for is, if people are using 2016 and they're not seeing the performing gains that they want, please send us your data. Send us your data with animation, because we'd rather have the animation that really exercises the rig the way that you want to use it, not the developer art that we can come up with.
Right.
And that way we know that we're focusing on the problems that matter the most to you. So this is an ongoing project. We know that there's still lots of gains to be had in rendering and evaluation, even more clever ways of doing some of the custom evaluation that we've discussed, and we're all actively thinking about how we can make this even better.
Awesome. And if people want more information?
Yeah, so if people want more information, I think there's going to be a Q&A session that accompanies this webinar.
Yep, we'll be chatting while it's going.
Yeah,
so.
and I'm also going to be releasing a white paper that explains some of the nitty-gritty of this stuff in more detail in the weeks to come. So stay tuned for that, and yeah, give us your feedback. We'd love to hear about it.
Cool. Well, thanks again, and thank everyone for taking the time to check out the performance improvements that were made to Maya 2016. Cheers, everybody.
Okay, bye.